sklearn, utils, sparseFinks, in-place column scale. Description. This function performs in-place column scaling on a sparse matrix. It scales each column of the matrix by dividing each element in the column by the maximum absolute value in that column. This can be useful for preprocessing sparse data before applying machine learning algorithms that are sensitive to feature scaling. Inputs. X. This is the sparse matrix that needs to be scaled. It should be a SIP, sparse matrix. Scale. This is an optional array that specifies the scaling factor for each column. If not provided, the scaling factor for each column will be calculated as the maximum absolute value in that column. Outputs. X. This is the modified sparse matrix with scaled columns. The original matrix is modified in place. Steps. The function first calculates the maximum absolute value in each column of the sparse matrix. It then divides each element in each column by the corresponding maximum absolute value. The function modifies the original matrix in place, so no new matrix is returned. Metrics. None. The function does not calculate any metrics. It simply performs the scaling operation. Visualization plots. None. No visualization plots are associated with this function. Fine-tune parameters. Scale. This parameter allows you to specify the scaling factor for each column manually. You can use this to adjust the scaling based on your specific requirements. Uncertainty methods. None. No uncertainty methods are directly associated with this function. Challenges and fixes. Challenge 1. Sample use case that resulted in challenge 1 if the sparse matrix contains columns with all zeros. The scaling factor for those columns will be 0, leading to division by 0 errors. Fixes to challenge 1. You can handle this by either replacing the zeros in the scaling factor array with a small positive value, e.g., 1e10. Or by removing the columns with all zeros from the sparse matrix before scaling. Challenge 2. Sample use case that resulted in challenge 2 if the sparse matrix contains columns with very large values. The scaling factor for those columns can be extremely small, leading to numerical instability. Fixes to challenge 2. To mitigate this, you can consider using a different scaling method, such as standardization, which scales each column to have zero mean and unit variance.